Hi, in this video, I'm going to discuss the next 8 questions, medium questions in SMC, Sljmcc 4, given last year, April, and the first 8 in Sljmcc 5. All right, let's go to the questions. Let me share my whiteboard. Right. Actually, in the first video, I discussed number 9 also. Now we'll start from number 9, right? So I will actually do 8 and 9 again because these are questions which has a common setting, right? All right. So let's do that. In the correct addition below, A, B, and C are non-zero digits, and D is a digit, right? What number is, okay, what's the maximum number D can be? So that's the question, right? Number 9, we start from number 9 and go until 16, right? So if A, B are non-zero digits, then the maximum A can be is 9 and B can be 9, right? A can represent 9, B can represent 9. So then A plus B was the maximum, has to be 18, right? So the maximum is 18. So the maximum number would be, it is actually 8, right? All right, so that's the answer to number 9. We go to number 10. So number 10 and 11 have a common setting. In the correct multiplication below, not addition, right? A, B, and C are non-zero digits, and D is a digit. What's the maximum number CD can be? Now there's a bar above this, right? Now it means that we mean the number, two-digit number, whose 10th digit is C and the 1st digit is D, right? So what's the maximum number this can be? So, we need to look at the maximum A can be, which is 9, and maximum B can be, it is 9. So 9 times 9, sorry, 9 times 9 is, we know that it is 81. So that has to be the maximum of this number, right? So it is 81. Number 11, what is the minimum number this CD can be? CD with a bar on the top. So it is a two-digit number. So what is the smallest two-digit number? It is 10, right? So can we get 10 as a product of two digits A and B? Well, yes, 2 times 5 is 10. So the minimum number CD can be is 10, right? So that is easy. So let's look at number 12. So 12 and 13 have a common setting. Arithmetic operations plus, minus, division, multiplication can be inserted in each of the 4 boxes below to get a correct equation. So we know equation, right? So these are actually like, so we can talk about left-hand side of an equation. So this is left-hand side. So when you look at this equation, right, what is to your left? What is to the left of the equation? That is the left-hand side. So this is the left-hand side. Now, maybe you have not learned about these things at school, but these are very important things when you go to higher grades, right? So this is the left-hand side. And this is the right-hand side, right? So this is my right hand, so right-hand side. And these are balanced. Equal means that, so they have the same so the same number on both sides. So these are actually numbers, right? So in the balance we have numbers, right? So that's an equation, right? Right. So let's look at the question. In how many different ways can a division or multiplication be inserted in each of the 4 boxes to get the correct equation, right? So only division and multiplication you can put into the boxes. There are 4 boxes, and in how many different ways you can get balanced correct equation, right? So we have 3 ones on the left hand side. So so now, so 1, right? uh, Division multiplication. So we have to get 1, right? Because 1 divided by 1 is 1. 1 multiplied by 1 is 1, right? So then there is this box here. Same situation, right? Because the result here, so this is actually 1, no matter what you put in the box. It could be division, could be multiplication. It's a 1, and again 1, box 1, the same situation. So we are going to get 1 here, right? So with division or multiplication, we're going to get 1. So we could put, all division, right? 1 divided by 1 divided by 1, we get 1, right? So we can get 1 on the left-hand side in 4 ways. Division, 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 multiplication, multiplication, division, multiplication, multiplication. So let me write them here. So, and then we have 1 divided by 1 times 1 is equal to 1, right? And then 1 multiplied by 1 and divided by 1 is 1, and 1 multiplied by 1 multiplied by 1 is 1, right? So we can get 1 on the left hand side in 4 ways. But can we get 1 on the right hand side so that we'll have a balanced scale equation? So 40 box, and then in parentheses, that means that we have to do that first. What is in the parentheses? 5 box 8. 5 divided by 8, you don't want to think about it, right? It's a fraction. You don't like fractions. And then 5 times 8 is 40. 40, here we can see how we can get 1, right? But 4 times, it's not 4 times 40. That's a big number. But 40 divided by 40 is 1. So 40 divided by what is in parentheses, right? Times 5 times 8. So this is 1, right? So what is the answer to number 12? We can get a balanced equation, balanced scale, in 4 ways, right? If we use only division and multiplication, right? So that is interesting. That was interesting, right? Number 13. In how many different ways can now we have subtraction in addition to multiplication, right? Subtraction, division, multiplication, right? We can use any one of those 3, and we have to get balanced scale, right? Polar balanced equation, right? So these 4 are there. We found in number 12 because it is actually, we can use any 2 because it's O here, right? Any 2. So those 4 are there. And then if you use minus subtraction, what happens, right? So if you use subtraction, right, you can see that there is no way you can get 1 on the left hand side, right? Let me erase this, right, so that we have a clear view of what we need to do. So what I'm saying is that with subtraction, there is no way you can get 1 on the left hand side. Why? Because, right, now here, right, if you use minus 1 is 0, right? 1 minus 1 is 0, right? And then, so 0 times 1 is 0, 0 divided by 1 is 0, 0 minus 1 is, of course, we don't want to think about it. We can't take away 1 from 0, right? Of course, we can in higher grades, but not in grade 4. In grade 4, we can't take away anything from 0 because there's nothing there. But in the higher grades, you can take away from 0. That's weird, right? But it sounds interesting, right? You want to learn how you can take away 1 from 0, right? Okay, right. Now, what happens, if you put now here doesn't matter if it is division, right? Multiplication, we still get 1, right? If you don't want to put a minus there, but if you put a minus here, you get 0, right? So if you're going to use minus here, right, that means you're going to get a 0, right? Right. So let's look at how we can get 0 on the left-hand side. The different ways you can get 0 on the left-hand side, right? Right. So let me get a different color, right? Okay, red. Important color, right? Right. So we can have 1 minus 1 times 1 is 0. So this actually to getting 0 on the left-hand side. And then we can have 1 minus 1 divided by 1. It is also 0 because 0 divided by 1 is 0. If you divide anything by if you divide 0 by anything except 0, we can't divide 0 by 0, right? We get, if we divide anything, if you divide 0 by anything, you get 1. So you get 0, right? And then we can actually have 1 divided by 1 minus 1, you get 0. And 1 times 1 minus 1 is 0. So there are 4 ways of getting 0 on the left-hand side. So what about the right-hand side? So this is left-hand side, right? What about the right-hand side? Can you get 0? Well, you know that with multiplication and division only, we can't get 0. So we need to use subtraction, right? So when you think about it a little bit and you scratch your head, and then suddenly you get this aha moment, bulb goes on, right? We can have 40 minus 5 times 8 is 0, right? 40 minus 40 is 0. And that means we can get 0 on the left-hand side in 4 ways and 0 in the right-hand side in 1 way. And that means we can balance the equation, balance the scale in 4 ways. And with this 4, right, we have a total of, right, 8 ways. And the answer is 8. Okay? Right. So that was even more interesting than the previous one, right? Right. So let's look at number 14. So let's go back to our cool color, which is light blue, right? That is my cool color, right? Praveen and Pavani have the same number of marbles, so they are, so I'm going to write like this, Praveen, Pavani, right? They have the same number of marbles. Diagrams are always better, right? We can see things. And then Praveen gives 11 marbles to Pavani, so his number of marbles go down by 11, right? Now he's here, 11 down, and then Pavani goes up by 11, right? So now you can see that, right? Now Pavani actually is, right, has 11 plus 11 more than Praveen, right? You can see that it is now 22. I mean, earlier they had the same number of marbles. Now actually, Pavani has 22 more than Praveen. So that's the answer, right? All right. Number 15. So let's go back to our cool color, blue. Mina thinks of a number, multiplies it by 31, and adds 7 to the answer. She gets 131. What is the number she thought? What do we know, right? She hasn't told us, but she has told us the final answer 131 after doing these two operations. So what if we do these two operations right backwards in the reverse order? We start with adding 7 to negate that, right? To get back to the original number she had before adding 7, we need to take away 7 from 131, right? You take away 7 from 131, what do you get? You get, let's see, 124, right? And then, so this is what she had before she added 7. Now, to get back to the number she thought at the beginning, we need to reverse engineer, right? This is multiplied by 31. So we divide by 31, right? To get, to find what she thought. So can we divide by this by 31? So it looks like, I mean, because there's a 4 here and 1. So what about it if you multiply this by 4? Yes, we get 124. Yes, that means she thought 4, right? And you can check. So when you multiply 4 by 31, you get 124. When you add 7 to 124, you get 131, right? So working backwards, we found that she thought 4, right? All right. Number 16. When each of the digits 5, 6, 7, 8, and 9 is placed in a square below. So you have to put all 4, right? 5 digits, 5 boxes. An addition of a 3-digit number and a 2-digit number is formed, right? What is the largest possible sum? So there are lots of ways of putting these 5 digits into these 5 boxes, and we get lots of sums. So we don't want to even think about those sums, right? It's too many, right? So we need to find a lazy way of finding this, easy way, right? Because when you are lazy in a way, you find new ways of doing things because you don't want to spend a lot of time in doing things. You want to find a smart way, right? So we know these boxes, right? These stand for place values, right? So this is the hundredths place of this 3-digit number, right? And this is tens place, right? And this is the tens place of the 2-digit number, and the 1 place. So we need to put the biggest digit into the hundredths digit, right? Place, right? Here 100. So 9 here, right? Let's use red. 9 here. And then we had 2 tens places, doesn't matter. So we put the next highest digits, bigger ones, into these. 7, 8, doesn't matter whether it is 8 there, 7 here, right? And 5, 6 in the ins places, ones places, doesn't matter whether it is 5 or 6 here, right? So how many hundreds? We have 900, right? So 900. How many tens? So 70, 80, and ones, 5, 6. So what do we get? 900. So this is 150. So this is 1050, right? And 1056. And that is the biggest largest possible sum, 1056, right? Okay, hope you got it. And if you didn't get, you can revisit, you can rewind the video and watch it. So watch and learn. But when you do the problems, right, as I always say, pause the video before I do the problem and you do it and watch the video. Okay? Okay. See you in the next video, right? In the next video, I'm going to discuss 17 to 24, the toughest 10. Okay? Sorry, toughest 8 in SMC 4, Sljmcc 4. Okay, see you then.